Okay, good afternoon, or I guess good morning, everyone. Um, you've been working on, or we've been working with polynomials for the last little bit here, and today we're going to get into talking about multiplication with a polynomial. Okay, um, we have seen a little bit of what we're going to do today in a different form last year when we talked about the distributive property. And so that's kind of where we're starting today. So if we think back to last year, we were given an expression in the form a, and then in brackets, as we see here, x plus b, x plus or minus b, right? So a times x plus or minus b. We learn that that coefficient represented by a would be multiplied by both the variable and the constant inside the brackets. Okay, so if you remember correctly, we did a lot of work with remembering that we were going to multiply the a by the x and then the a by the b, and doing that to both of them. We did a little bit of this in our algebra work in back in November. Okay, so here in this example, I'm going to go 4 times n and 4 times 6. So really, I have 4 times n, and then I have subtract 4 times 6. Okay, meaning I get 4n minus 24. I'm not expecting you to show that extra step with a question like this, but it might come in handy here in a second when we start talking about monomials, multiplying by a constant or a monomial. Okay, so then here I've got negative 5, so I got negative 5 times d and negative 5 times positive 6. So I go negative 5 times d, oops, plus negative 5 times 6. Okay, so I get negative 5d, sorry that's messy, and I get plus negative 30. Okay, again, same thing. 6 times negative 3 and 6 times negative n, so I get negative 18 minus 6m. And then here, this is really important. So we go x times x, and we go x times 5. So we know that x multiplied by x is going to give us x squared. We have to combine those two, okay? That is part of that exponent law. That's not 2x, okay? That's x times x, which gives us x squared. So we get x squared plus 5x, okay? And that is probably what we need to focus in on the most here going forward. But we want to talk a little bit first, as we've seen with polynomials, about how they're going to be represented. Okay, not necessarily just in the work that I give you, but also in the work that we're going to see as we continue to move forward into future years, but also at the end of the year in our PAT. So thinking back, we learned about the area model, and maybe it wasn't from me, maybe I know we've kind of talked about it in passing over the last 2 years, but when multiplying. So we can kind of decompose this a little bit, right? This 36 times 43, okay? If I thought of this as 36 times 43, now obviously not drawn to scale at all. I could even break that up a little bit more, and I could say, all right, I'm going to get rid of that 36. I have 30, and then I have 6, right? There, and then I have 40, and I have, draw a line there, 3. This is what we mean by the area model. Okay, so if we look at just this rectangle, if we called that A, we would have 30 times 40, we get 120. This rectangle, if we called it B, we go 40 times 6, or sorry, that'd be 1200, not 120. 40 times 6 would give us 240. 3 times 30 would be 90, and 3 times 6 is 18. And then I'm just going to add all those together. Okay, so we get 1200, we get 240, we get 90, and we get 18. It's okay if you don't remember this model, but basically what I'm doing is I'm taking, and rather I'm doing exactly the same thing I would be doing if I did long multiplication. But what I'm doing is I'm modeling it, okay? And if you kind of think about it, it starts to look a little bit more like our what we've seen with polynomials, okay? So what you're being asked to do is multiply 2 by 4x. And so on the next page or in the next slide, I'm going to go into a little bit more detail about this and with kind of the pages from your book that aren't a part of your note package, but you can look at it in your book as we go through this, okay? But this idea that we're multiplying 2 by 4x. Oh, okay. Let me zoom back in here. And we want to draw it as an area model, okay? So the 4x, as we know, is rectangles. I'm going to draw them horizontal today, just because we've kind of been drawing them vertical. I've been doing a lot of things, okay? So I have 4x. That's one group of 4x. Okay, that's one. If I added a second group of 4x, like this, we now see that we have 8x, right? And that kind of makes sense. Like if I go 2 times 4x, right? If I multiply the coefficients together, it makes sense that that becomes 8x. That's just kind of, you know, I hope that that just kind of makes sense to everybody if we go 2 times 4x. But when we're talking about this area model, you'll see in the drawings on the next page, they actually do it quite closer. But then you have x, 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 x. So they almost make it almost like a rectangle that you can't even see the difference in between all of them. So I'm going to try my best here. 1, 2, 3. Starts to look like what we did when we did fractions, right? So we call that x, and we call each of those 1, right? So we have 2 on this side, and we have 4x here. It starts to change a little bit how it looks. Ooh, don't like that marker. Just want to do this green here. Okay, starts to change a little bit how it looks for us. All right. So this is from our book, okay? And this is kind of what I was meaning, is that if you had this expression 4 times 3x, okay, they're saying it's a product statement. So it represents the product of the constant 4 and the monomial 3x. So we're doing basically 3x plus 3x plus 3x plus 3x. Remember, multiplication is just repeated addition, okay? But they drew it like this. Oh, look, it's right down there. Way to pay attention, Mr. McKenzie. So they drew it like this. Obviously, much neater when it's done by a computer than done by my hand. But they have this idea that, okay, they went 3x, okay, long in one row. They have 3 x's, and they made 4 rows, okay? This is what they mean by that area model. You could also do it like this. This is the second method they use, okay? Again, we're just using a rectangle. We got 3x on one side and 4, and that kind of makes sense. If we go 4 times 3 times x, I like how they write this, 4 times 3 times x, because if we remember the commutative, that word I love so much and have such a hard time saying, property, right? Order of operation doesn't matter. 4 times 3 times x, if we break it apart like this, it doesn't matter the order we do them in, but it becomes this 12x, okay? So that's kind of something to think about there. You're only multiplying the constants together, but you're getting that same idea. As we kind of keep going down, there's a couple examples here with negatives. Not the end of the world. It's going to be, we have negative 4 times 3x, same idea. Doesn't really change anything with the drawing, except for us, we would shade it in. In the book, it's going to be red, okay? And then again, this is now moving. So we have, and we're going to get into a little bit more of this, but I'll just zoom in a little bit. If you're looking at your book, I forgot to say, we're on page 243 now. We can use the distributive property to multiply a constant or a monomial by a binomial or a trinomial. Same idea. We're going to go and we're going to multiply that 3 by that negative 2m and that 3 by that plus 4. And in this case, we're going to multiply that negative 2 by each of the terms in here. That means that I could have a constant -2, say, and like I could have 5 or 6 terms in the brackets, and I would multiply this -2 by each of them. Okay, so it goes through a little bit here how to draw this. Okay, so one thing to focus in on, I'll zoom in a little bit here. It drew -2m, or in our book they drew -2m plus 4. Okay, we see that there. This little row here is the -2m plus 4. Okay, and then they created 3 rows of that, as we can see. So they have 1, 2, 3. If we were to sit here and count, we're going to see that we have -6 and we have -12. Well, that's pretty easy to think. 3 times -2m is going to give me -6m, and 3 times 4 equals 12. That kind of makes sense, right? All of that makes sense. When we use the distributive property, okay, if we multiply 3 times -2m and 3 times 4, we get that same thing. Okay, they're showing this multiplication in a second step. I'm going to ask that you guys do that maybe a little bit too, just so we see that you're doing it correctly. The other way they're going to draw this is, especially with a trinomial, you see here they're doing the same idea. They're doing 2 rows. Okay, they drew the trinomial. This is -n squared. This is n and n, and that's a -1. So that means we have this -n squared plus 2n minus 1. They drew 2 rows of it. Because it's negative, they're going to switch to the opposites. So they're just flipping the tiles over. Now, in the algebraic, not algebraic, but in the symbolic, when we use numbers, okay, if we multiply this out over here on the right side, okay, we get 2 times -1n, or -2 times -1n squared plus -2 times 2n plus -2 times 1. So that gives us 2n squared plus a -4n plus 2. And for some reason, they rewrote that without the plus the -4n. Pretty simple, pretty straightforward. Okay, so again, just a little bit of a reminder. You're going to line up the 2 factors to form edges of the rectangle if we're being asked to draw it. You're going to complete the area of the rectangle with appropriate fitting algebra tiles to determine the answer. And then you multiply positive and negative forms of negative value. Multiply 2 things of the same sign of forms of positive value. So let's show this. Okay, so we have 2x plus 3. So I'm just going to first draw the x plus 3. And mine's going to look a little bit bigger. I apologize for that, but we're going to try and make this, you guys can make it as small as you need. Okay, so I have that x plus 3, x, 1, 1, 1. And then if I do another row here, okay, I have the same thing. I have 1 and 1. Okay, so that means that I have now 2x, plus 6. Algebraically, or if I use the distributive property, if we want to use that terminology, okay, I have 2 times x plus 2 times 3, and then 2x plus 6. Okay, this is what I want to see from you guys. I want to see this step for now. Okay, I'll let you know when you don't have to do this step. But for now, to make sure we're doing it right, we want to show that we're multiplying each term between the brackets by that monomial in front. Okay? So just give you a second to copy that if you need. And you can always pause it too if you need to. Okay, so this time we have a -x and a 2x minus 1. So realistically, I have a -x, just so happens I'm using red, but I'm going to shade it in, on this side. And then I have 2x's here and a -1 here. Okay, and in your book, it's going to kind of show it this way where it has this, it almost looks like a graph or maybe the margins of a piece of paper, right? So I kind of like this drawing with this because what it is I now have the 2x minus 1 here and I have the negative x here, okay? So when I multiply negative x by x, I am going to get a negative x squared. I'm going to color that in, shade that in. And then I do the same thing and I actually have a negative 2x squared. And then I multiply this negative and negative, and we know that a negative times a negative gives us a positive. So this symbol, this part in here, under kind of in this margin that I'm outlining in yellow right now, that becomes my answer. So my answer is negative 2x squared plus x. Okay, if I do this algebraically, okay, and I go that and that, I get negative x times by 2x, okay, and minus, and I'm going to go plus a negative x times by negative 1, okay? So think about this for a second. I have this hidden coefficient of, let's just rewrite it, negative 1x there, okay? So I'm going to multiply the negative 1 by the 2, and I'm left with 2. X times x gives me x squared. And then I have a negative and a negative, so those become a positive. So I get the same answer. I forgot to throw my negative in there. But I get that same answer of negative 2x squared plus x. Pause it for a second if you need a second to finish copying that. All right, so these are pretty straightforward. They're just kind of that practice piece, right? When we're multiplying a monomial using algebraic approach, ensure that every term is multiplied. So we're just practicing this a little bit, okay, by the monomial. Every term inside the bracket is multiplied by the term outside the bracket. This term is referred to as a distribution. Coefficients multiply coefficients, variables multiply by variables, okay? So in this, I have the coefficient negative 4 times by the coefficient 5x, or the term 5x. I have the constant negative 4 multiplied by the monomial negative 5x, okay? So I multiply the the coefficients together, negative 4 and 5. That gives me negative 20, and I'm left with x, okay? Here, oh, sorry, I should have done this. Recall up here, x squared, x times x gives me x squared. And then if I have x times x squared, you have to remember x squared is like x times, oh gosh, let's maybe not do that many x's. Okay, so x times x, we'll do that. And then, so what we end up having is x times x times x, which is also x to the third, or x cubed. Okay, 2x times 3x, well 2 times 3 is 6, and x times x is x squared. Take a second, maybe pause the video and do the next ones on your own. Okay, so I filled in these here. We got here in the top right, negative 15x squared. Here we have a positive 3x to the cube, okay? Remember, this negative here and this negative here are going to give us a positive. 10x squared, and then negative, that's really messy. Sorry about that. Negative 21x squared here. Okay, 21x squared. Pretty simple, but kind of good little practice in order to make sure that we have that, because it's going to come in big here in a second. Okay, a few more here. Whoops, don't need that big red mark. Let's zoom in a little bit. Awesome. Okay. Again, last year when we learned how to do distributive property, I would often have you guys make the arrows. I like the arrows. It's a good practice, okay? But like I said, I also want you to show what you're doing. So I have 3 times 2x plus 3 times 4, like that. So then I get equals 6x plus 12. Okay, I'm going to do one more example, and then I'm going to have you pause the video and do the next couple on your, or the next 4 on your own, the rest on this page, I guess. So I go 2x times by 3x plus 2x times by 5. So 2x times 3x gives me 6x squared, and then I get plus 10x. So pause the video and take a few minutes and try the next ones on your own. Okay, so I did 2 more here just for everybody to look at. You can see that in this first one here, okay, I distributed them. I have a negative 3x times 2x minus negative 3x times 8, which gives me negative 6x squared minus a negative 24x. And I just took that minus negative 24x and turned it into adding 24x. So not entirely necessary, but you have to be prepared for that. As we keep saying, you might get a list of answers that none of them look right if you stopped, at this step. But you have to recognize that maybe they're going to write this portion like I did here in the 3rd line. Okay, that might be something they try to do just to get you to do that. It's not required, but it's it might be something they try to do. Next one, negative 3 times a negative 3y plus negative 3 times 7. So I get 9y plus negative 21. So real quickly, in these next ones, I've switched over to blue ink. I'm going to stick with that for a second. Remember, I said when we have this monomial or constant at the first, and now it's a trinomial, we still multiply it by everything in those squares, okay? So I'm going to do 2 times x squared minus 2 times 4x plus 2 times 6, okay? So then I get equals 2x squared minus 8x plus 12, okay? Same thing here. Do the exact same thing. I'm going to multiply each one, okay? So I'm going to just do it under here for a little bit more room. I get negative 3n times by 4n squared plus negative 3n times by negative 6n plus negative 3n times by 11. Okay, so then I get, I'm going to multiply the coefficients together, so I get negative 12, and the n times n squared gives me n cubed, plus the coefficients together, negative 3 times negative 6 gives me positive 18, and n times n gives me n squared, plus negative 3 times 11 gives me negative 33n. Okay, there you go. And again, they may rewrite it as minus 33n. Who knows? Just a couple more pages here. Again, this is an example of a little bit more of a larger problem, okay? Steps really don't change. We're going to treat each part kind of on its own, okay? So, like, if you wanted, strategy here might be to add square brackets around all the ones that you have to multiply together, okay? I'm not a huge fan of that. I'm just going to go ahead and do it. But it's not like I'm going to do 4 times this, times that, times that, times that. No, we're not doing that. That's a big no, okay? The 4 only is multiplied by the 2x minus 3, okay? So I'm going to go that times that and that times that. So I go 4, 2x plus 4 times negative 3 plus, and then I have 6x times by x. So actually, I'll change color to make this a little bit easier so we actually see that. Okay, so then I'm going to go 6x times this and 6x times that. So I get plus 6x times by x. Let's go plus 6x times by negative 2. Okay, then I go plus again, switch colors again. Let's go green this time. And I'm going to kind of consider this as a negative 5. So I'm going to go negative 5 times x squared and negative 5 times 1. So I'm going to go negative 5 times x squared plus negative 5 times by 1. Okay, so then once I multiply all this, I get 8x plus negative 12 plus 6x squared plus negative 12x plus negative 5x squared plus negative 5. Okay, and I'm not done because I have to simplify it. So now I have to combine like terms. Okay, so I'm going to reorder by degree. So I had positive 6x squared equals, so I've done that one. I'm actually going to switch colors completely here. So equals 6x squared plus a negative 5x squared, and I think that's all for the x squares, yep, plus 8x plus negative 12x, and then plus negative 12 plus negative 5. Now I can combine like terms. So color change again. Those two combine to just become x squared. Those two combine to become negative 4x. And those two combine to become negative 17. So I have x squared plus negative 4x plus negative 17. So again, we have to simplify. We do each of the distributions. We have to simplify then by creating or by grouping like terms. So I'll just give you a second to copy that and then we'll keep moving on. All right, so again, we're multiplying. Now, really important here. There's two steps here, two things we need to recognize. So we have a distribution here, but then we have a subtraction, okay? So we're combining a couple things here. So I'm going to do this distribution first, okay? So I get 3y times 4x plus 3y times negative 1, and then I have minus 3xy plus 5. Okay, so I'm going to do the multiplication first because BEDMAS would say we would do multiplication first. Okay, so I get equals 12xy plus a negative 3y. Okay, now remember when we're subtracting, we continue, we add the opposite, okay? So we're going to go plus a negative 3xy plus a negative 5 or minus 5, whatever you want to do. You just want to add the opposite of 3xy plus 5, okay? So I'm going to just put that back to minus 5, okay? So now I need to group like terms. I'm not going to reorder them. The two that are like here are 12xy and negative 3xy. So if I add those together, I get 9xy. And then the other two are just, they don't have any like terms, so we're just going to copy them out. Negative 3y minus 5. And that's kind of how you have to do that one. There was no constant here, okay, so we didn't have to do any distribution. But you want to make sure that you're just paying attention as well. We're combining ideas here, okay? Give you a second to copy that one. All right, so as we've seen a lot in this unit, there's lots of perimeter questions that they like to do with polynomials, okay? So we're going to do another one here. I just got to get the video a little bit right. Now, first thing, I hope that you're thinking to yourself is, by this point is, okay, I have to find a couple sides here. I don't know what this side is, and I don't know what this side is. How do I find those? Okay. Realistically, what you have to do to find them is look for the difference between this side and this side. And then also for the difference, I should have done those ones in red. Anyhow, yeah, let's circle those ones in red. So for the red side, you have to do that. And then for the green side, you have to find the difference between those two. Okay, so what I'm going to do is I'm going to show that first. This is my full side on this one, and this is my full side on that one. So I'm going to show that. Okay, how do I do that? So I'm just going to erase all these scratch marks. Sorry if I missed some of them, but I'm going to consider this. Okay, I need to know what the difference is between 7x plus 8. So as a polynomial, 7x plus 8, a binomial, minus 3x plus 3. Okay, so as we saw, we're going to go 7x plus 8 minus 3x minus 3. Okay, or I could do plus a negative 3x plus negative 3. Okay, which leaves me pretty simple one. I'm not going to regroup them. 7x minus 3x is leaving me with 4x, and then 8 minus 3 is leaving me with plus 5. And that kind of makes sense. If I think 4x plus 5, okay, 8 and 7x plus 8. Okay, so this side here is 4x plus 5. That is the first piece of work I have to do. Okay, and then I have to do the same for these two. I got to figure those two out. Now, you don't necessarily, I'm showing you this work, you don't necessarily have to do that. I think most of us could look at the difference there and say, okay, this is going to be 2x. I hope so anyways, because if I look at this 5x plus 3 minus 3x plus 3, okay, I'm going to get 5x plus 3 minus 3x minus 3, and when I combine all those and get group-like terms, the 5x minus 3x gives me 2x, and 3 minus 3 gives me 0. So now I have that, okay? Here's the thing. We now have to find the perimeter. So we're going to add up all of these sides. So I'm going to go 2x plus 7x plus 8 plus 5x plus 3 plus 3x plus 3. I'm going to run out of room here, guys. Plus 3x plus 3. Yeah, I'm just going to keep writing underneath. 4x plus 5. Okay? So, we're adding everything. There's no negatives here. I could regroup all of this. I'm not going to. I'm just going to try and count this in my head. Okay, we got 2x plus 7x is 9x. Plus another 5x is 14x. Plus 3x is 17x. Plus 3x is 20x. Plus 4x is 24x. And then we're going to go 8 plus 3 plus, it gives me 11, plus 3 gives me 14, plus 3 gives me 17, plus 5 gives me 22, I'm pretty sure. 2, 9, 12, or 14, 17, 20, 24, 8, 11, 14, 17, 22. Yep, so my perimeter is equal to 24x plus 22. Now, give me a second to copy that. Okay, so it then asks us for the area of the shape. So we've seen a little bit with compound shapes. We're going to divide this here. Okay, so we have a square here. We have 3x plus 3 times 3x plus 3, and then we have 2x times 7x plus 8. Okay, so I'm going to write that. So for the area, we have 2x times 7x plus 8. We're going to do all of that one, and then we go plus, I'm going to put some 3x plus 3, and I'm going to put that in brackets, and I'm going to explain why in a second. 3x plus 3. Okay. All right, I'm going to zoom up a little bit. We're not going to be able to see the shape on the video, but we're going to move up a little bit. Okay. Now, this might not necessarily be something that comes up in the future, and if you don't understand it after this explanation, that's okay. We'll get into it a little bit more in class. We should be able to do this by now. 2x times 7x and 2x plus 8. So I get 14x squared plus 16x. And then I'm going to leave that as a binomial just like that. Now, here's the fun part when we're doing a binomial times a binomial. Okay, I have to multiply the 3x by the 3x and the 3x by the 3 from the first binomial to the next binomial. I have to do that. I also get to do this, 3 times 3x and 3 times 3. This is a binomial times a binomial. We multiply everything in the first binomial by everything in the second binomial, each one individually. Okay, if you think about that area model that we did at the first, where I forget the numbers, I think it was something like 36 times 43. I hope that's right. So if I go 30 plus 6 times by 40 plus 3, when I drew that, right? I'll zoom up a little bit here so we can see that. Oh shoot, sorry folks. When I drew that, okay, and I went like this, and I had 30 and 6 and 40 and 3, okay? I went 30 times 40, so 30 times 40, and I got 1200. And then I could have went 30 times 3 and got 90. And then if I had gone 6 times 40, I got 240, and 6 times 3, and I got 18. We're doing the same thing up here. Okay, we're doing that same thing. So when I do all of that, I get, so when I go 3x times 3x, I get 9x squared, and 3x times 3, and I get plus 9x. And then I go 3 times 3x, and I get plus 9x. It's a little bit hard to see, so I'm going to erase this big long green line. I guess I can't. Okay, and then I go 3 times 3, and I get plus, or 3 times 3, yeah, and I get plus 9. Now if I group all these like terms, okay, I get 14x and 9x squared, so I get 23. Excuse me, I just sneezed. I hope you guys didn't hear that. 23x squared, okay, and then I'm going to group all the x's together. I get 16 plus 9 plus 9, so 16 plus 9 is 25, plus 9 is 34x plus 9, and that is my area. A little bit more of a complicated question. We'll get into more of these in class. Okay, and then the last part of this is just finding x, or the perimeter for x equals 4 centimeters. So then I'm going to go back up, and you can kind of see it on this video, and I'm going to take this p equals 24x plus 22, and I'm just going to substitute the x or 4 for x, plus 22. 4 times 20 is 80, plus 4 times 4 is 16, so 96 plus 22 is equal to 98, 118 centimeters for my perimeter. Okay. Might have seemed like a long video. Probably is a long video. I hope you're able to get through it all in the one class. But if you have questions, hold on to them. Try the questions that you're going to be assigned. But we can definitely get into this the next class. Have a good day, everyone.